Hello everyone, I welcome you all to this first lecture of Waves, Oscillation and Acoustics. In this course, we'll start with oscillation, then we'll move on to waves, and then end with acoustics. Now, before jumping on to the details, let us first see what do we mean by waves, oscillation and acoustics. And also, let's see why we tend to always study waves and oscillation together. Let us start with wave. So, what is actually a wave? Well, a wave is actually a periodic disturbance that transfers energy. You can see a lot of examples of waves around us. For an example, say you have a pond with still water, and if you throw a stone in that pond, it will create a disturbance that will be periodic in nature and that will carry the energy of the stone towards the periphery of the pond. This was one example of wave for which you need a medium. We call this kind of wave a mechanical wave. And there is another kind of wave which do not actually need any kind of medium. An example of that is electromagnetic waves. Now, when a mechanical wave propagates through a medium, the particles of the medium starts to oscillate. Now, let's see what happens in case of a wave using a simulation. Here you can see some kind of wave is going on the surface of, say, this pot of water. So you can see that wave is passing from left to right, maybe. Now, as you can see, the particles are moving, but is it oscillating? Well, oscillation means, are they moving about some point and coming back to that point? Well, let's see. If we enable this show circle, we see that here this red particle actually moves in a circle like this. And here this particle also moves in a circle. So you can see that similarly all the particles are coming back to the same position where it started, and it's periodic in nature. So that means that the particles of the medium are oscillating while a wave is passing through that medium. The particles of the medium can oscillate in the direction of the movement of the wave or in the direction perpendicular to the movement of the wave, or maybe a combination of both. When the particles of the medium oscillate in the transverse direction to the direction of movement of the wave, we call that wave a transverse wave. Here you can see an example of a transverse wave where you can clearly see that the particles here are oscillating up and down in this direction, and the wave is moving in this direction. Now, in this diagram, you can see how particles oscillate in case of a longitudinal wave. Here you can see that the particles are oscillating in this plane or this direction, which is actually parallel to the direction of movement of the waves. And the example that we saw earlier in case of water wave, their oscillation of the particles was a combination of both of these oscillations, transverse and longitudinal. Now let us have a look at another simulation. Here you can see that this particle is undergoing some sort of oscillation. Actually, we call this type of oscillation simple harmonic oscillation. We'll come to this in the next video. Now, if we just increase the number of particles undergoing this similar simple harmonic oscillation, it will look like this, right? So all the particles are in same phase and they are doing exactly the same simple harmonic motion. Okay? Now, if we just increase the number a little bit, well, you can see all the particles are again doing the same simple harmonic oscillation. And if we just increase their separation, well, that means their phases are different. Can you see that some kind of wave seems to be moving through this? Well, if we increase the separation a little more, yeah, you see that? It looks like a wave now, right? Let us just increase the number a little more. You see? So this is an example of transverse wave, which is moving in this direction, and the particles, as you can see, are oscillating in this direction. Well, now you know how mechanical waves propagate through a medium. But what about electromagnetic waves? How do they propagate? Well, we'll come to that in the later part of our course. Now let's concentrate on oscillation. So, what is oscillation? Well, oscillation is a kind of periodic motion. What is periodic motion? Well, periodic motion is a kind of motion that repeats after a certain amount of time. For example, the motion of the planets around a star is an example of periodic motion. The ticking clock is an example of periodic motion, and you can go on forever. And what is oscillation? Well, it is a kind of periodic motion where the object moves for an amount of time in a certain direction and for an amount of time equal to that in the other direction. Like these examples shown here. As you can see, these particles are moving in this direction for a certain amount of time and in the upper direction for the other half of the time. Okay, so you see this kind of motion is going on, right? Actually, this oscillation here is a special type of oscillation which we call simple harmonic oscillation. And when we call an oscillation a simple harmonic oscillation, well, we'll come to that later in this next video. Okay, now let's move on to the last part of our course, which is acoustics. So what is acoustics? Well, acoustics is a branch of physics which deals with the study of mechanical waves, especially through gases, liquids, and solids. And it includes the topics like vibration, sound, ultrasound, and infrasound. So you see, acoustic mainly deals with the behavior of sound waves. In our course, we'll mainly focus on wave and oscillation, and we'll have a small number of lectures on acoustics. So this is what we will talk about in the next few weeks.